Good morning, class. My name is Len Chamberlain, and this will be my discussion on SSH or Secure Shell for Professor Green's ISA 4220 course. A little overview on what we'll be doing. As usual, we're going to go over what it is, how it works, and a couple hardening practices you can use on your boxes. So SSH. SSH stands for Secure Shell, and it's a protocol used for communicating over a network that can be implemented without being expensive. In fact, it's free and it's relatively simple. The early version of SSH is SSH1, whose main focus was replacing Telnet and providing security for remote logons. SSH provides more basic client-server capabilities as well, and can be used to secure other network functions such as file transfers of backups or anything else you may need to retrieve, like other FTP traffic. And it's also the most common way of safely administering remote servers if you don't accidentally create rules in your IP tables to prevent communication. OpenSSH is part of the SSH protocol implementation. It was developed from the release of SSH1 by the same creators of OpenBSD once it was announced that SSH would not be free to use commercially. SSH has since become readily available for free of charge again, but OpenSSH continues to be a widely utilized option as Open Secure Shell has been created by the community at large over the years, like many other open source software, like Linux. SSH is ideal for keeping data confidential and ensuring its integrity as it's exchanged over the network in between systems. SSH for both the client and server applications have a broad availability for most operating systems. It has become the method of choice for remote login for administrators. SSH uses a client-server model in order to authenticate multiple parties and allow encrypted traffic to pass between them. The server listens on port 22 by default for requests to generate a connection. Once received, the server portion is responsible for negotiating the connection and the authentication. The client is responsible for initiating the communication and verifying the server's integrity by various means, such as using certificates, ensuring it's from a trusted certificate authority, like with other protocols we've discussed. When a session is first initiated by the client, the server will respond with the protocol version it supports, and then, if the client can utilize that supported version, the process of encrypting the traffic begins. This is done by utilizing the Diffie-Hellman exchange. The Diffie-Hellman exchange, as we've discussed in other presentations, is an asymmetric key exchange that is used to pass a shared key securely between the client and the server in order to encrypt all further communication for the session. The use of a shared key is known as symmetric encryption. The importance of using symmetric encryption is for speed and efficiency. It just takes a lot more time and resources for asymmetric encryption. The process by which Diffie-Hellman exchange takes place, I've actually outlined here because I find it pretty interesting. So the first step is both parties agree on a large prime number, which will serve as a seed value, and then both parties agree on an encryption generator, which will be used to manipulate the values in a predefined way. Independently, each party comes up with another prime number, which is kept secret from the other party. This number is used as the private key for this interaction. It's actually different than the private SSH key used for authentication. The generated private key, the encryption generator, and the shared prime number are used to generate a public key that is derived from the private key, but which can be shared with the other party. Both parties then exchange their generated public keys. That's unencrypted. That goes over the air. Anyone can see that. The receiving entity uses their own private key, the other party's public key, and the original shared prime number to compute a shared secret key. Although this is independently computed by each party using opposite private and public keys, it will result in the same shared secret key. It's fancy mathematics. That's why it's very interesting to me. I'm not very good at math, but the fact that mathematics can come up with solutions to these problems, I find very fascinating. That shared secret key is then used to encrypt all the communications that follow. After this process is complete and the session is using asymmetric encryption, the user must be authenticated to the server. The client can be authenticated to the server using the authentication protocol SSH TAC user auth, which provides multiple mechanisms to authenticate the user. The easiest process is username and password. SSH user auth is used for authenticating the client to the server using the connection that has already been established and runs on the transport layer. While username and password may be the simplest, the most popular and the recommended manner is the use of SSH key pairs. The process in which this happens is like this. The client begins by sending an ID for the key pair it would like to authenticate with to the server. The server checks the authorized key file on the account that the client is attempting to log into for the key ID. If the public key with matching ID is found in the file, the server generates a random number and uses the public key to encrypt the number. The server sends the client this encrypted message. If the client actually has the associated private key, it will be able to decrypt the message using that key, revealing the original number. The client combines the decrypted number with the shared session key that is being used to encrypt the communication and calculates the MD5 hash of this value. The client then sends this MD5 hash back to the server as an answer to the encrypted number message. The server uses the same shared session key and the original number that it sent to the client to calculate the MD5 value on its own. It compares its own calculation to the one that the client sent back. If these two values match, it proves that the client was in possession of the private key and the client is authenticated. Once authenticated, the client is able to access the server to retrieve files, input commands, and manipulate the server in numerous ways. One popular console that is used, and one which I use to configure switches and routers regularly, is PuTTY. PuTTY is an open source application that you can find readily available online. It is a very lightweight and powerful tool for administrators. So a couple hardening techniques in order to boost the security of your system that is utilizing SSH. One is to limit users' SSH access. So using the password or public key, all users in the system can log on SSH as default. This gives them complete access to all tools that are on the system. You need to allow root access via SSH to particular users by going to sshd_config file and putting allow groups or allow users with the names and groups of users that are allowed. You can also decide to use the deny users if you want to deny only a few users while allowing everyone else. So that's kind of like the whitelist and blacklist approach. Another thing we can do to harden is to disable password authentication. We'll get to that in just a little bit after we discuss SSH keys. But another thing you can do is to deny host to prevent access to your server from outside networks or specific IPs of your choosing, and to monitor those who attempt to connect. The deny host package can be installed. This is important on any server that has SSH active and is configured by following a couple easy steps. You just do the sudo apt-get install deny host. Once that installs, you just open up the configuration file located at etc/host.allow, and you're going to want to sudo nano that in order to manipulate the file. Then you're just going to list all the IPs that are permitted to access the server. That will by default block every IP that's not in that file. There is a host.deny file that you can manipulate that has other configurations you could utilize. It's a little bit beyond the scope. So utilizing SSH keys for authentication, we touched on it earlier, but I wanted to go over it again for hardening policies. So while username and password authentication is simple to use and implement, it is considered bad practice for SSH authentication. This is due not only to the user's propensity for generating short and easy to guess passwords, it is also because the attackers have the ability to use powerful GPU password cracking devices to decrypt these short passwords after being intercepted, thus circumventing password security. SSH keys are nearly impossible to brute force utilizing the previously described password cracking practice. In order to set up and use SSH keys, all that is needed is to generate a key pair and place the public key on the remote server while maintaining a private key on your client machine. This is done with the following steps. So we're going to create the key pair with that simple command. Then you're going to store the key and the passphrase. After inputting the command, a few questions will be prompted. One's asking for the location you'd like to save the file, and another is asking if you'd like to use a passphrase. If you just leave that blank, there won't be a passphrase. You just hit enter. But what that passphrase does is it prompts you for a password when it wants to use that file. And then you'll copy the public key to the remote server. You can use that command there. The SSH copy ID user at .xxx is going to be the IP address of the remote server. Or you can just paste the command with that second, or you can just paste the file with that second command. So once that's done, and obviously you used a username and password to get connected prior to that, you're going to want to disable password authentication. To disable password authentication, all you have to do is navigate to sshd_config, and then within that file, you're going to change the variable for password authentication to no. By default, it's yes. And that'll drastically improve the security of your server. And that was my presentation on SSH. I look forward to hearing and seeing everyone else's presentation, and I hope everyone has a great weekend. Thank you.